Hello, everyone. Welcome back to Global Math Mentor, your go to place for mastering SAT math with clarity and confidence. Today, we're diving into a powerful and practical topic from the digital SAT exponential growth and decay. You see these types of problems everywhere: population changes, investments, bacteria growth, radioactive decay, and yes, they show up often on the SAT. We'll start with a quick breakdown of the key formulas and what they mean. Don't worry, no fluff, just what you really need to know. Then we'll jump straight into solving real SAT style questions step by step so you can see exactly how to tackle them with speed and accuracy. So grab on your calculator, stay sharp, and let's crack this together. Let's take a look at the growth and the decay functions. So the exponential growth looks like this: y equals to a, 1 plus r to the power of t. And the decay function looks like this: y equals to a, 1 minus r to the power of t. So you can see that there is a difference of sign. There's a plus and there's a minus, where a is the initial value. This value can be a quantity. This can be anything which is given in the start of the experiment. And r represents growth or decay rate. This number is given as a percentage, so we convert it into decimal and then we apply its value. T is the number of time intervals. The time intervals, usually they are given in years, but sometime in months, half yearly, quarterly, and so on. So I'll give you an example where you can understand how to write an exponential function. For example, in a town, there were initially 1,000 people, and the population, let's say, increases at the rate of 5%. And 5% can be written as 0.05 if I convert it into a decimal. How do you write an exponential function for this situation where t is like the time in years? So y equals to the initial value, which is given, and 1 plus a 0.05 to the power of t. But in the SAT, this number is rarely given like this. It's usually given like 1.05, like a single number. So the base of the exponential function can tell you a lot about the shape of the graph. And I'll talk about the sketch as well, how you can sketch this thing. But right now, look, this clearly shows that this value is more than 1. So this will represent a 5% gain. Okay. And on the other hand, like if, for example, a car was initially 8,000 worth dollars, let's say, and each year its value depreciates by 10%. So you might look at a function like this somewhere, 0.9, which is actually correct. Why did I write it as 0.9? Because 1 minus is 0.1. 10% is a 0.1. So when you subtract 1 minus 0.1, that becomes a 0.9. So this kind of a function will straight away represent a 10% loss. So that's a decay function. Now, how do the graphs of these functions? Well, you can check in the graphing calculator how does it look like. But this graph over here will look something like initially when time is, like, let's say, zero, the year zero, so it's somewhere at 1,000. So this is the y-intercept of this exponential function, and it will go all the way like this. So that is how this exponential function will look like. Well, you can check it. Just open the graphing calculator and check it yourself. And on the other hand, the decay function will look like, I mean, initially it was 8,000 somewhere. So this is the y-intercept of the graph. You know where the horizontal component is 0. This goes downward like this and gets flatter towards the x-axis. So none of these graphs ever descend the horizontal axis. X-axis is like, let me just make it more clearly. X-axis is like a horizontal asymptote. I mean, the x-axis can be t-axis. I'm not mentioning the variables right now. For according to my situation, it's y against t, but it can be y against x or p against q. It doesn't matter. So why it never gets negative? Keep in mind that an exponential function's value is never negative unless until there's some sort of transformation applied to it. That I'll talk about in later videos, like what's the function transformation. You can check in your Desmos, like if a is multiplied with a negative number, if you put a negative here, this will become reflected in the x-axis. And similarly, if you have -3 or something. That kind of a transformation, like it descends the graph, drops it 3 units downward and upwards. But that's a different situation. So, what's the key takeaway from this lesson? So, let me just write it here. If you have y equals to a, b to the power of x, if b is greater than 1, this will be an exponential growth. And if y equals to a, b to the power of x, and b is within 1 and 0, this will always be an exponential decay or an exponential decrease. Let's dive into some actual SAT style questions. Problem 1, a radioactive substance decays at an annual rate of 13%. Well, I know that this is an exponential loss. If the initial amount of the substance is 325 grams, which of the following functions F models the remaining amount of the substance in grams t years later? So, well, each of the option represent an exponential function. So I know that the initial amount is 325, and then I can write 1 minus, what's the 13%? That's a 0.13, and to the power of t. So 325, and if you subtract 1 minus 0.13, that's going to be 0.87, and to the power of t. So by this, I know that A is the correct answer. Even if you don't want to write this exponential function like this, you can save time and clearly look at the basis. Well, this is not a 13% loss. It's just 13%. So this is incorrect. Why these are incorrect? Oh, ballpark the incorrect option since we know that the initial amount of the substance is not in the right place. It should be here, comparing it to the exponential loss function, which is a 1 minus r to the power of t. So this way you can answer these questions. Problem 2. In planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. Okay, it's not every year, it's every 20 years. If the present population of the city is 50,000, which of the following expression represents the engineer's estimate of the population of the city T years from now? So we know that it's 50,000, and then we have 1 minus a 0.1, which is a 0.9 to the power of something. So ballpark the incorrect options. Why these are incorrect? Because it's just a 10%. I need a 10% loss. So one of the C and the D is correct. But there is a little problem. The powers you can see are different. There's a 20t in C and T divide 20. So how do you identify which is the correct? Go back to the statement again. So they say that, read it from here. The population of the city will decrease by 10% every 20 years. So if I put t equals to 20, the population should become 10% less. So this should be 0.9. So in which expression do you think? So if you put t is equal to 20 in the C part, this will become 50,000 and 0.9 to the power of 400, which is definitely not a 10% loss. But if you put it here, that 20 divide 20 in the power will become 1, and the population will decrease by 10%. So D is the correct answer. Problem 3, the function f of x is given by this, models the value in dollars of a certain bank account by the end of each year from 1957 through 1972. So this is the initial year, 1957, and then so on. This function is representing some amount in the bank. Which of the following is the best interpretation of f of 5 is approximately equal to 243 in this context? So let's see. Option A, the value of the bank account is estimated to be approximately $5 greater in 1962 than in 1957. So if you add 5 to 1957, you get 1962. But this value is not, you can see that the initial value was 206 and now it's 243. So it's way more than 5. So this is incorrect option. Okay, B part. The value of the bank account is estimated to be approximately $243 in 1962. So if I put 5, well, I can see it's 243, but let's take a look at like what exactly is the value? 206, bracket 1.034, and to the power of 5. So that is approximately 243. So, well, there's nothing wrong about this option. This seems promising, correct? Let's take a look at the incorrect options. Why C and D are incorrect. The value in dollars of the bank account is estimated to be approximately 5 times greater in 1962 than 1957. Well, no. If I well, you can see that it's 243, so it's not 5 times greater. If you multiply 206 by 5, that will be way greater than 243, so this is incorrect as well. So the value of the bank account is estimated to increase by approximately $243 every 5 years. No, this is incorrect as well. So we know that 206 is the initial amount, and 1.034 is some gain factor, and x is the power. So this is an exponential gain question, and B is the correct answer. Problem 4. This is another exponential problem. The function f gives the value in dollars of a certain piece of equipment after X months of use if the value of the equipment decreases each year by P%. Okay, P% is like the percentage decrease factor of its value the preceding year. What is the value of P? Well, there are some options, and you can guess as well since the base is 0.64. So we know that this is 1 minus a 0.36. So this is C is the correct answer. But if you want to don't want to guess it this way, you can write the exponential decay function 1 minus r to the power of t, which is x over 12 in this case, and just equate this 1 minus r to 0.64 and get its value. So you will find out that r will be 0.36, which is a 36% loss. Here goes problem 5, which is an exponential function again. And I mean, you can guess it this way. This is an exponential loss function since you can see that this value inside the bracket is below 1. Just giving some extra information. Okay, the given function f models the number of coupons a company sent to their customers at the end of each year, where t represents the number of years since the end of 1998. And t is within 0 to 5. That's like the domain of the function. If y equals to f of t is graphed in the ty plane, which of the following is the best interpretation of y-intercept of the graph in this context? So, I mean, you can check it with the graphing calculator as well, but I'm just going to sketch it anyway. So it's y against t. And I know that when t is 0, you will get 8,000 because from your indices, the power rule, you know that anything raised to power 0 is a 1. So the value when t is equal to 0, f of t, which is the y value, is going to be 8,000. So the graph goes like this. Since it's an exponential decrease, so it is within 0 and 5. So this is what the graph of this function will look like. So let's look at the options. So the minimum estimated number of coupons the company sent to their customer during the 5 year was 1428. So, I mean, minimum should be 8,000. Oh, but the word minimum, come on. Nowhere does it say minimum. It just models the the number of coupons the company sent to their customers. So this is incorrect. And the minimum estimated number of coupons company sent to their customer during the 5 year was 8,000. I mean, this can be a tricky option. So when T0 the value of the function is 8,000, but nowhere does it say anything about the minimum estimated number of coupons. So this is an incorrect option as well. The estimated number of coupons the company sent to their customer at the end of 1998, we know this is the end of 1998, but that is not 1428. So this is incorrect as well. So by ballpark, I can say that D should be the correct answer, but let's read it. The estimated number of coupons the company sent to their customer at the end of 1998 was 8,000. So, well, there's nothing wrong about option D. Option D is correct. Problem 6. The world's population has grown at an average rate of 1.9% per year since 1945. Okay, so it's increasing the population. There were approximately 4 billion people in the world in 1975. Which of the following function represents the world's population P in billions of people T years since 1975? And 1 billion, they have mentioned it. Like, what exactly is this? So, I know clearly that C and D are incorrect because have you noticed these are just linear functions? So population models are never linear, they are exponential functions. So now I'm going to set my one of these A and B is correct. Let's see which one is correct. So 4 is the initial value, which is in the correct place for both functions. And 1 plus this is a 1.9%. So a 1.9%, if you divide by 100, becomes a 0.019 to the power of t. So this becomes 1.019 to the power of t. So I know that A is the correct answer. Problem 7. So we see an exponential function, m equals to 1800, 1.02 to the power of t. So this is again a gain function. The equation above models the number of members m of a gym t years after the gym opens. Of the following, which equation models the number of members of gym q quarter years after the gym opens? So let's take a look at the options. A, m equals to 1800, which is in the correct place, 1.02 to the power of q or 4. The other one is similar, but the power is 4q. C is not similar since the base doesn't match with the actual function. This is an incorrect option, and this doesn't match with the actual function as well. So ballpark these incorrect options. So I need to figure out which of these A and B is the correct answer. So if you observe this exponential function, 1800, and this is like a 1 plus a 2%, like which is a 0.02, and it's a gain function, and it should give me like a 1.02, like a 2% every quarter years, right? So there are 4 quarters in a year. So if you put Q equals to 4, you will see that in one of the quarters, it will be increased by 1.02. So clearly A is the correct answer. Why B is incorrect? Because it is increasing this function way faster. It is taking 4 full quarters. So that is incorrect. So A is the correct answer. Problem 8. The graph of the exponential function h in the xy plane, where y equals to h of x, has a y-intercept of d. Okay, so the y-intercept should be d, where d is a positive constant. Which of the following could define the function h? So I mean, what does it mean by y-intercept of d? So if you put x equals to 0 in the given graph, the value of y should be d. So if you put x0, this doesn't give you d. If you put x0, this doesn't give you d. This gives you 0. If you put x0, oh, this is a 0. So if you put x0, 3 raised to power 0 is 1. So you get d. So d is the correct answer. You get it? Like y-intercept means where x is 0. Problem 9. The half-life of a certain substance in an aquatic environment is about 150 years. Half-life, okay. Which of the following exponential functions best models the amount 80 in grams of a substance t years after 200 grams of substance is applied to the aquatic environment? The half-life is the length of time needed for an amount of the substance to decrease to one half of that amount. So initially there's 200 grams. So A and B are incorrect because we know from the exponential models. So this is 200, and you can see that in each of the inner value, it's given a half-life or a 50% or a zero point 0.5. So we know that this function should have something, this 200 gram of substance. And now let's see which one of the C and D is a correct option. So one of the option is 150 T. So every 150 years, oh, this will definitely be incorrect. You know that if you multiply 150 with 150, it will not half it. Instead, it will do something else with it will drop it further. So the option D, let me just erase it and tell you why option D is correct. T over 150. If you put T equals to 150, every 150 year, this becomes 1. So you get 200 times the half, which will make it 100. So D is the correct option. Problem 10, P of t 90,000, 1.06 to the power of t. An exponential gain function. The given function P models the population of Lowell T years after the census. So T is in years. Which of the following functions best models the population of Lowell M months after the census? Okay, so we need to look at the functions. So A is definitely incorrect. Nothing to do with this 12 here. We know it's 90,000 and 1.06. So if you try to convert this, there are how many months in a year? So we know that if you a month is like a 1/12 of a year. So M divide 12 should be your answer. So D is the correct answer. You can clearly see that in each of the other options, you can see the 12 in the wrong place. So ballpark these and D is the correct answer. And that wraps up our final question on exponential growth and decay. If you have followed along till now, you're well on your way to mastering one of the trickier algebra topics on the digital SAT. Remember, it's all about understanding the formula and identifying what's growing or shrinking. If this video helped you, give it a thumbs up and don't forget to subscribe for more SAT strategies and practice walkthroughs. Got questions? Drop them in the comment. I'm here to help. Keep practicing, stay confident, and I'll see you in the next one. This is Global Math Mentor, over and out.